Hi, I am Rochi and I am from Group 5, Class MAM26. Now, my teammates and I are going to present about transformation of function. So, there are four types of function that we have studied. It is linear function, quadratic function, cubic function, and square root function. And there are also two types of transformation. One of the transformation is translation. It is written in the form fx plus a and fx plus a for a bigger than 0 and a smaller than 0. The another transformation is reflection. It is written in the form f negative x and negative fx.
Linear function. It is written in the form of f bracket x bracket equal mx plus c. For example, f bracket x bracket equal 4x plus 2. By comparing with the general formula, y-intercept is 2 and it crosses the graph at y equals 2. By comparing with the general formula again, the gradient is 4. Translation of linear function. For f bracket x plus a, when a bigger than 0, it shifts to the left. Originally, the blue line represents fx, the x-intercept is negative 3, 0. The red line that represents f bracket x plus a is shift 2 units to the left and x-intercept now become negative 5, 0. For f bracket x plus a, when a smaller than 0 is shift to the right. The blue line that represents fx, the x-intercept is negative 3, 0. The red line that represents f bracket x plus a is shift 2 units to the right, and now as we can see, the x-intercept become negative 1, 0. Translation of linear function. For f bracket x bracket plus a, when a is bigger than 0, it shifts outwards. As we can see from the first diagram that initially the blue line f bracket x bracket equal 5x plus 15, and the y-intercept is 0, 15. When a equals 2, and the line shifted 2 units outwards and the y-intercept now becomes 0, 17. When a is smaller than 0, it shifts downwards. As we can see from the second diagram, the blue line that represents 5x plus 15, the y-intercept is 0, 15. When a equals to negative 2, it shifted 2 units downward and the y-intercept now becomes 0, 13 on the red line. Reflection of linear function. For f bracket negative x bracket, it is reflected about y-axis. For the first diagram, for f bracket x bracket and f bracket negative x bracket, the blue line and the green line are mirror image of each other about the y-axis. For negative f bracket x bracket, it is reflected about x-axis. So for the second diagram, for f bracket x bracket and negative f bracket x bracket, the blue line and the green line are mirror image of each other about x-axis.
When ax squared plus bx plus c. Example would be x squared plus x plus 1. Translation of quadratic. F bracket x plus n when n is positive and when n is negative. When n value is positive, it will shift the graph to the left by the amount of n, and when n is negative, it will shift the graph to the right by the amount of n. The reason for this is according to the equation of negative b divided to a, when your n is negative, your b value will be negative, which when you multiply by negative again, it will become positive value, which will give you a positive vertex. And when your n is positive, it will give you a sum of b is positive value, and positive value multiplied by negative, it will give you negative values, and therefore it will give you negative vertex. F of x plus a, and when a is greater than 0 and when a is smaller than 0. When a is greater than 0, it will shift the graph up by the amount of a, and when a is smaller than 0, it will shift the graph down by the amount of a. The reason for this is what the a does in this case will only affect the c value. Meanwhile, the other function, the other translation I mentioned earlier, will be affecting the ax squared and bx. Reflection of graph. F bracket negative x reflection line will be on x equals 0. The reason for this is what it does is just sub negative x into the x value, which negative x multiplied by negative x will become positive x, which is also the reason why the graph still remains in positive x squared. Meanwhile, the other case, negative of f of x, what it does is multiply the whole entire graph by negative value, which will give you the negative curve. This is also why it's reflecting on y equals 0.
The cubic function is written in the form f of x equals ax cubed plus bx squared plus cx plus d, where a, b, c, and d are real numbers and a does not equal 0. The basic cubic function is f of x equals x cubed, and the parent of all cubic formulas is y equals x cubed. And on the left is the graph of y equals x cubed, and on the right is an example of another cubic graph, which is a transformation of y equals x cubed. For all the examples I will be providing, y will equal to x cubed. So for fx plus a, for a is greater than 0, means that the graph will shift a units to the left. For example, fx plus 2, the graph will shift 2 units to the left, and the new graph will be y equals x plus 2 all cubed. And the point 1, 1 will now be minus 1, 1. So for fx plus a, for a is less than 0, will mean that the graph will shift to the right by minus a units. For example, fx minus 2 means that the graph will shift 2 units to the right, and the new graph will be y equals x minus 2 all cubed, and the point 1, 1 will be 3, 1. For the translation, where f of x plus a, for a is greater than 0, means that the graph will shift a units upwards. For example, f of x plus 2, the graph will shift 2 units up, and the new graph will be y equals x cubed plus 2. And the point 1, 1 will now be 1, 3. For f of x plus a, for a is less than 0, means that the graph will shift minus a units downwards. For example, f of x minus 2 means that the graph will shift 2 units down, and the new graph will be y equals x cubed minus 2. And the point 1, 1 will now be 1 minus 1. For the reflection of cubic graphs, f minus x will reflect the graph in the y-axis, and minus fx will reflect the graph in the x-axis, and they will produce the same graph. For our example, y equals x cubed, f minus x will produce the graph y equals minus x cubed, and that will be the same for minus fx. However, for f minus x, the point 1, 1 will be minus 1, 1, and for minus fx, 1, 1 will be 1 minus 1.
Square root functions. The square root function can be written as f of x equals to square root of x. The diagram shows the graph of square root function. The graph can also be drawn by using the table. The square root function is a one-to-one function because by referring the graph, it does not intersect horizontally. The square root function is always positive because a function can only have one value for each input. For example, by adding a -2 value, it becomes a one-to-many function, which means it's not a function. Translation of square root graph. For f of x plus a, when a is greater than 0, the graph is shifted to the left. For example, when f of x plus 2, the graph is shifted 2 units to the left. When a is less than 0, the graph is shifted to the right. For example, when f of x plus -2, the graph is shifted 2 units to the right. For f of x plus a, when a is greater than 0, the graph is shifted up. For example, when f of x plus 2, the graph is shifted 2 units up. When a is less than 0, the graph will be shifted down. For example, when f of x plus -2, the graph is shifted down by 2 units. When we combine both of the conditions of translation, we'll notice that the graph will be shifted horizontally and vertically. For example, f of x equals to square root of x plus 2, then the graph will be shifted to the left by 2 units and shifted up by 2 units. Reflection of square root graph. For f of -x, the graph is reflected horizontally. For example, the general formula for square root graph is reflected on y-axis. By referring the diagram, the red color represents f of x and the green color represents f of -x. For negative f of x, the graph is reflected vertically. For example, the general formula for square root graph is reflected on x-axis. By referring the diagram, the red color represents f of x and the green color represents -f of x. And that's all from our group. Thank you so much.